You're at a campsite, and your water bottle just ran dry. 10 feet away, a stream is running clear and cold over smooth stones, and it looks perfect, the kind of water they put on bottled water labels. And 10 feet past that, you watch a deer walk up to that exact same stream, put its face in, and drink like it's nothing. No hesitation, no boiling, no filter. It'll do that again tomorrow and the day after, for its entire life. If you did what that deer just did, there's a real chance you'd spend the next week on a bathroom floor, wondering what you did to deserve this. Maybe worse. So here's the question worth sitting with. How is it that an animal with a brain the size of a lime can safely drink water that would put a fully grown human with our giant brains, our science, our medicine, into a hospital bed? What does a deer know about survival that we somehow lost? Here's the assumption most people are walking around with, and it's almost exactly backwards. We tend to think of wild animals as tough, and humans as soft, like nature hardened them, and civilization softened us, and that's just the cost of progress. Comfortable modern humans, ruined by soap and antibiotics and bottled water, while the real survivors out in the wild shrug off whatever nature throws at them. It's a nice story. It's also not really what's happening. Animals aren't drinking dirty water and walking away unscathed because they're tougher than you. They're doing it because, over millions of years, evolution rigged the game in their favor in ways your body was never built to match, and in some cases, humans actually used to be a lot closer to that tough end of the spectrum than we are now. We didn't get weaker by accident. We traded it away. Start with the baseline, because this is where it gets interesting fast. Almost every wild animal you can name, deer, raccoons, elephants, wolves, birds, routinely drinks from water sources loaded with things that would wreck a human gut. Giardia lamblia, Cryptosporidium, E. coli, Leptospira bacteria, assorted parasitic worm larvae, and whatever runoff happens to be draining into that water from decomposing carcasses upstream. This isn't rare contamination. This is standard wilderness water, basically everywhere on Earth. A 2018 review published in the Journal of Wildlife Diseases documented Giardia and Cryptosporidium as essentially ubiquitous in wild mammal populations across North America, present, tolerated, and largely asymptomatic. Meanwhile, the CDC estimates Giardia infection alone sickens roughly 1.2 million people a year in the United States just from drinking untreated water, and that's in a country with some of the cleanest natural water sources on the planet. Same water, wildly different outcomes. So what's actually different? But here's where it gets complicated, because the answer isn't one single trick. It's a whole stack of overlapping defenses, and the first one starts before the water even reaches the stomach. Start with stomach acid, because this is the first line of defense, and it's honestly kind of brutal. Human stomach acid sits around a pH of 1.5 to 3.5, genuinely acidic, strong enough to dissolve a lot of what we swallow. But compare that to a vulture, whose stomach acid has been measured at close to pH 1, among the most corrosive digestive fluid of any land animal on Earth, according to research published in the Proceedings of the Royal Society B in 2014, led by biologist Michael Roggenbuck. That acidity is strong enough to destroy anthrax spores and botulinum toxin bacteria so dangerous that a single gram of botulinum toxin could theoretically kill over 1 million people. A vulture eats that for lunch off a rotting carcass and digests it like it's a granola bar. Now look at carnivores. Generally, lions, wolves, hyenas. Their stomach acid regularly measures more acidic than a typical human's, an adaptation directly tied to eating carrion and drinking from whatever puddle happens to be nearby. Your stomach acid, by comparison, evolved for a diet that included a lot of cooked food, which meant your ancestors didn't need industrial-grade acid to neutralize raw bacterial loads the way an obligate scavenger does. Cooking did some of the work stomach acid used to have to do. That's a trade, not a flaw, but it's a trade that leaves you exposed the moment you're drinking straight from a stream with no fire in sight. Now here's the part almost nobody talks about, and it's arguably the bigger factor. It's not really about the individual animal at all. It's about the entire population playing out over generations, in a process that's less like toughness, and more like a very slow, very ruthless optimization algorithm running in the background of every species on Earth. Think about what natural selection actually does to a wild population that regularly drinks contaminated water. Every generation, some percentage of animals get sick from waterborne pathogens. Some of those animals die before they reproduce. The ones who survive and reproduce are, on average, the ones whose immune systems and gut microbiomes happen to handle that specific regional cocktail of pathogens a little better. Repeat that process for thousands of generations, and you get populations that are locally adapted survivors of exactly the pathogens in exactly that watershed. This is why a deer drinking from a specific creek in Vermont isn't necessarily equipped to handle a totally different set of pathogens in a creek in Costa Rica. Local adaptation is hyperspecific, built by generations of exposure to that particular ecosystem's particular threats. Humans used to run on a version of this same process. Populations with long histories of exposure to certain waterborne diseases developed measurable genetic resistance research on cholera resistance in Bangladeshi populations, with centuries of exposure to Vibrio cholerae, published in Science in 2017 by a team led by Eleanor Carlson, found specific genetic signatures under strong selective pressure, directly tied to cholera survival. The mechanism is identical to what's happening in a deer population. We're not exempt from it. We just mostly stopped needing it. And that leads to the part of this that most people have never even considered, because it's not about acid or genetics at all. It's about who's actually living inside the water in the first place, and here's where the story flips in a genuinely strange direction. What looks like wild, untouched natural water is not actually water in its natural state most of the time. It's water that's been altered by us. Here's the uncomfortable irony. Some of the deadliest contamination in wild water sources today, E. coli blooms, agricultural runoff, antibiotic-resistant bacteria, is a downstream consequence of human civilization. Farms, livestock operations, septic systems, and urban development leaching into watersheds that animals have been drinking from for generations. A 2020 study in Environmental Science and Technology tracking watershed contamination across the continental U.S. found antibiotic-resistant bacterial strains in wild water sources correlating directly with nearby agricultural density. So in a strange way, when a modern human gets sick from wild water, they're sometimes getting sick from a mess. Their own species created a level of contamination. The local wildlife's evolved defenses were never calibrated for either, because it didn't exist a few hundred years ago. This is part of why wildlife disease researchers have documented rising outbreaks of illness even in wild animal populations near heavily developed areas. The water isn't just naturally dirty. Increasingly, it's dirty in new ways nobody, human or animal, has had time to adapt to. Here's the twist, and it's the detail that really recontextualizes this whole story. The thing that actually makes humans vulnerable to dirty water isn't really about biology at all. It's about something we invented roughly 12,000 years ago that fundamentally rewired what our bodies expect, and it happened so recently, in evolutionary terms, that it barely registers as a blip. Fire and cooking go back much further, over 1 million years by some estimates. And clean water infrastructure, plumbing, filtration, chlorination is even more recent, really only universal in the last 100 to 150 years in the developed world. That's not even a rounding error against the roughly 200,000-year history of anatomically modern Homo sapiens. For over 99% of our species' existence, humans drank straight from rivers, lakes, and streams, exactly like every other animal, and endured the exact same consequences. Sickness, death, brutal infant mortality from waterborne disease, being one of the single largest killers of children throughout most of human history, according to historical epidemiology estimates cited by the World Health Organization. We were never actually built to safely drink dirty water. We just spent the last sliver of our existence engineering our way out of needing to, and in doing so, we let a lot of our ancestors' hard-won tolerance atrophy, because evolution doesn't keep defenses you're no longer using. A trait that stops mattering for survival isn't maintained just out of nostalgia. It gets neutral, then it drifts, then it's gone. Clean water didn't make us fragile by accident. Clean water made toughness against these particular pathogens pointless to keep, and biology, ever the ruthless accountant, cut the expense. Now for a story from a totally different corner of biology that reinforces this exact same theme, just from an angle you probably haven't considered. Bearded vultures, also called lammergeiers, native to mountain ranges across Europe, Africa, and Asia. Their diet is close to 90% bone. They eat the skeletal remains of dead animals, swallowing bone fragments whole, sometimes dropping large bones from great heights onto rocks, just to crack them open first. Research published in the Journal of Raptor Research has documented their digestive tract handling bone fragments, along with the bacterial load riding along on decomposing carcasses, using a combination of extraordinarily acidic stomach fluid and a shortened, efficient gut that processes potential pathogens fast, before they get a foothold. This is an animal whose entire survival strategy is built around eating what would kill almost anything else on the planet, humans very much included. And the reason it works isn't mystical animal resilience. It's the same underlying principle running through every example in this video. Millions of years of relentless selection pressure, specifically shaped around one narrow ecological niche, producing a body that's a hyper-specialized tool for a very specific, very disgusting job. Take that same bearded vulture and expose it to a totally novel pathogen its lineage never encountered, and its defenses might do nothing at all. Specialization cuts both ways. Now the important caveat, because this video is not, under any circumstances, an endorsement of drinking untreated water because animals do it and they're fine. That would be an actively dangerous misreading of everything just explained, so let's be precise about why. Wild animals absolutely do get sick and die from waterborne pathogens. Wildlife mortality from disease is a real, documented, ongoing pressure on populations, not some myth debunked by this video. We simply don't see it as often because sick or dead wild animals tend to vanish quickly, picked off by scavengers or hidden in underbrush, while a sick human ends up in a hospital chart. Survivorship bias makes wild animals look invincible, when really we're just not seeing the failures. On top of that, human vulnerability to contaminated water isn't some flaw to be ashamed of. Modern sanitation and clean water access remains one of the single greatest public health achievements in human history, generally credited with adding more years to average human lifespan than nearly any medical breakthrough of the 20th century, according to public health historians. The CDC and WHO are unambiguous on this point. Untreated surface water, anywhere in the world, should be treated as unsafe by default, filtered, boiled, or chemically purified before drinking, no matter how clear or how remote it looks. Clear water is not clean water. A mountain stream that looks like something out of a shampoo commercial can be carrying Giardia cysts 100 yards downstream from a decomposing elk carcass you never even saw. If you're ever actually in a survival situation without access to clean water, boiling for at least 1 minute or using a proper filter rated for biological contaminants isn't optional caution. It's the difference between a bad story you tell later and a medical emergency. So here's where all of this actually leaves you. Every time you turn on a tap and clean water comes out, without a second thought, without even the concept of risk crossing your mind, you are living inside one of the strangest, most recent, most fragile privileges in the entire 200,000-year run of your species. For nearly the entirety of human existence, drinking water was a gamble, exactly the way it still is for that deer at the stream, exactly the way it still is for hundreds of millions of people around the world today who don't have reliable access to treated water. This isn't ancient history everywhere, it's this week's reality for a huge portion of the planet. The version of roughing it that shows up in survival TV shows, where someone confidently drinks from a wild stream and shrugs it off, isn't a display of toughness. It's usually a display of luck, edited before the consequences show up. Your ancestors paid, generation after generation, in sickness and death, for whatever partial resistance they managed to build, and then, in the blink of a geological eye, we engineered our way out of needing that resistance at all, and the trait quietly walked itself out the back door. Because that's what biology does with anything you stop needing. Next time you're standing at the edge of some perfect, glass-clear stream, remember what's actually separating you from that deer drinking 20 feet away. It's not toughness. It's not evolution favoring them over you. It's 12,000 years of your own species engineering, standing invisibly between you and a mouthful of water that's been trying to kill primates since long before there were primates to kill. Drink from the tap. Let the deer have the stream.